Next, let me go to the displacement. So let's see what is the displacement and how we calculate the cc or the cubic centimeters. Let's go ahead. This is a part of the piston and the cylinder. So here the engine size is measured in cubic centimeters or the cc or the liters. So we generally call it as like 1.5 liter, 2.5 liters, like that, right? So let me see how it is. And it denotes the cumulative volume of all the cylinders in the engine. So and the higher cc denotes the bigger size of the engine. Next part of the engine. So let's see what is the displacement. So here the engine size is measured in cc, that's a cubic centimeters, or in liters. So it is like this. So if it is like 1000 cc, it's 1 liter. It's like that. So it denotes the cumulative volume of all the cylinders of the engine. So the higher cc indicates the bigger size of the engine. Hope you remember we spoke about the TDC and BDC. There's a top dead center and the bottom dead center. So here it is. So this is a TDC, this is a BDC. The piston moves the maximum towards up will be the top dead center and the down will be the bottom dead center. So this is the piston and this is the cylinder. So this is taken here and I'm going to make it here bigger. So here what happens is the bore size. So from this corner till this corner will be the bore, and from this part till this part will be the stroke. The stroke is that the TDC to BDC, the movement is known as stroke. So inside the bore and the stroke, what is the volume? It's taken as the displacement. So displacement is measured in cubic centimeters or centimeters cube. That is, it's in the 3 dimension, right? So we have 3 axes like this, and then the depth. It's like that. So here it is. So that is, bore will be having 2 axes, 2 dimensions. Then comes the stroke. That is the third one. So here the cubic centimeters or in liters. So example, here in this particular engine, it denotes the cumulative volume of all the cylinders of the engine, right? So here what happens? Example. So each cylinder is of 500 cc. So it's altogether it is 2000 cc. So 2000 cc or 2000 cubic centimeters, or we call it as 2 liters. So 2.0 liters. So in some cars you would have seen, like for example, Fortuner, it will be having 3.0, the 3.0 in the old Fortuners, and now in the new Innova, if you see like in the Crista, it will be 2.4. So that is, it is the cumulative of all the cylinder sizes will be taken as 2.4 liters. That is 2400 cc. Next, let me see what are the valves. Every cylinder has at least one inlet and one exhaust valve to allow entry of air and exit of burnt gases. Higher the number of valves per cylinder will be having better breathing, more better breathing, which will be resulting in more better performance. So here, these are the valves. So valves are the ones like doors for the cylinder. Example, this is the shopping center. You're going to a mall or a shopping place. So you want to go buy some things, right? So when you enter the mall, you need to enter through the entry gate. You are entering from the entry gate and you are purchasing, and after billing you are going out. So going out will be through the exit door, exit gate only. And here the exit door will be controlled by the doorman who will be opening the exit door. So the valves are like doors. So these doors are controlled by this doorman. So that is the cams. So next we are going to speak about the cams also. So these are the valves. So valves are like doors for the cylinder. So you got to know about the valves now. So let me go to the cams next. So these are the cams or camshaft. So camshaft will be the one which will be opening the valves and closing it. Exactly that particular timing. When you come to the shopping center, right? So the doorman will open the door. Hello sir, please welcome to our store. Then when you get inside, he'll close the door. And after all the shopping done, you're going out, right? At the time when you're going out, there'll be another doorman who will be opening the exit door, open the door, and he'll tell you, thanks for visiting us, please come again. So after that, the exit door will be closed. So that's how the valves and the cams. So valves are like doors, controlling those doors are the doorman, like the cams. In this system, we have two types. One is the single overhead cam, another is the dual overhead cam. So let me see the single overhead cam first. Single overhead cam will be controlled by single camshaft, which will be having the rocker arm to open the valves and close it. So single overhead cam will control both the inlet and the exhaust valves. In that case, it is a single overhead cam, but having 2 valves per cylinder. Even a 4 valves per cylinder also can have a single overhead cam. The advantages and benefits of the single overhead cam. So advantage is that lesser moving parts. The benefit is that lesser load on the engine, so lesser noise and the lesser maintenance cost. So next is the dual overhead camshaft. In dual overhead camshaft, what happens is there are 2 valves, right? For that, individual camshafts will be controlling the inlet and exhaust valves. So one set of inlet valves will be controlled by one camshaft. The set of exhaust valves will be controlled by the separate camshaft. So there are 2 camshafts. So that is the dual overhead camshaft, which will be handled by the engine. For single overhead camshafts and dual overhead camshafts, 2 valves per cylinder is possible. Even a 4 valves per cylinder also possible. Either way, whether it's a single overhead camshaft or the dual overhead camshaft. So there's the advantage and benefits of this is that in dual overhead camshaft, the precise valve operation is possible, so that you get more power and less restricted airflow to the engine, so lesser emissions. So there's something called variable valve. So variable valve timing is that camshaft will have that advance or delay type of opening and closing of the valves. So in that, like according to the timing, if you need the performance, it will have a more opening or lesser opening depending on the driving conditions. The variable valve timing technology adjusts the timing of the engine's intake and exhaust valves by advance and delay method, resulting in improvement of performance, fuel efficiency, and exhaust emissions. There are three things in this. So that is timings. In the timing, we have the valves opening and closing as per the piston position or the movement. And there is another thing is like valve lift control. So lift control, how far the valve has to open, whether it's normal or it has to open more for more better airflow for better performance. And duration, how long the valve has to be open, so that will be decided by the variable valve technology. So we have single variable valve timing and we have dual variable valve timing. So how it is? There's a inlet and exhaust valve control, right? So in VVT, that is single VVT, that will be having only for the inlet. The control or the advance or the delay system will work only for the inlet. Exhaust will be as usual. If it is dual variable valve timing, the both the inlet and the exhaust camshafts will be having the advance and the delay system. So this ensures more better performance and better fuel efficiency and lesser emissions. So in different brands, they have different way of telling the same technology. Like example, in Toyota we call this VVT-i, that is variable valve timing with intelligence. In Honda we call this i-VTEC, so that is intelligent variable valve timing and lift electronic control. VVT variable valve timing will be used by Suzuki, and we have VTVT, so variable timing valve train, so that will be by Hyundai. And we have the VVA. VVA is that variable valve actuation. It is for like Yamaha. So today we learned about the displacement and we learned about the valves, cams, and the cam technologies like variable valve technologies. So that's all about today. Next upcoming videos, let me see about the engine fuel systems. So that will be with the evolution of the petrol fuel systems and the evolution of the diesel fuel systems. See you in the next session. Till then, take care. Bye.